Yeah. Okay. The odds are at 4, so that means it's time for Space News. What time does the Space and Rocket Review start? Right now, Crafter. Right now. I went to bed at 4 a.m., Tessa, and I woke up. I shut my alarms off in my sleep, and then I just woke up, quote unquote, naturally, at 7:30 after the launch, after it had already gone. And that booster flew DM2, which is crazy. Yep. Alright, so that's going to do it for Minecraft for now, guys. I play Minecraft every Saturday during the day. If you're interested in the city build project, yeah, that's when we do it. So, anyway, I'm going to take a quick break here. I'm going to take a quick break, and then we'll watch a replay of the launch cane during Space News. So we'll start the rocket review now, but I'm going to take 15-20 minutes and just chill for a second. There we go. Cool. Alright, I'll be back in a little bit, guys. Don't go anywhere. Plenty stream left.
A thrill a minute, neck twisters, spine shakers. Rides like this are a lot of fun, once in a while, and for some people. But few of us would like to do very much traveling over the waves of a roller coaster. These are only a few of the devices that man has invented to give himself a thrill and a pain in the neck. Sudden ups and downs are all right in an amusement device, but automobiles haven't much use for them. The automobile engineers know that in our motor cars, we want comfort and a smooth, level ride. Even when we want to travel on the level, the ups and downs, the waves in the Earth's surface, complicate the problem of getting a smooth, comfortable ride. The bumps and dips in the Earth's surface over which we travel have been reduced. Great progress has been made in leveling and smoothing out roads and highways. But automotive engineers have long known that all roads can never be made perfectly smooth. Even the smooth, paved roads have long, gradual waves, or small, sharp bumps that have different effects at different speeds. The wheels of our motor cars follow these waves, moving up and down with each change in the surface of the road. So to give us the smooth, level ride we want, engineers knew that the smoothing and leveling would have to be done by the motor car itself. Between the moving wheels and the passengers, some sort of a bump leveling device is needed. Let's see for ourselves the method by which the engineers have approached and solved this problem. Here is a wheel, fastened so that it is free to move up and down. The wheel rolls on a moving belt, rising and falling whenever it strikes a bump. A platform, fastened solidly to the wheel, carries a tracing pen, and when the wheel moves up and down, the tracing pen draws a line which shows the movement of the platform. To get a true picture of the up and down movements, the tracing paper moves at the same speed as the moving ground belt. We'll start the model running. Now, the traced line gives us an exact picture of the up and down movements of the wheel and platform. Let's see what happens when we use more speed. At high speeds, the effect of a bump is considerably greater. In slow motion photography, we can see that the wheel climbs the bump and bounces into the air. Of course, this jolting is passed on to the platform. We can mount a fairly stiff spring underneath the platform to see how it will affect the jolting. Now, let's watch it in slow motion photography. The traced line shows that we have cut down the jolting because the spring absorbs some of the effect of the bump. Let's substitute a soft spring for the stiff spring that we have been using. A softer spring gives a smoother line because a soft spring is able to spread out the effect of the bump and act as a better cushion against the jolt of the wheel. But when there are 4 wheels mounted in 2 sets, front and rear, as in the motor car, the problem is complicated.
Go at throttle up.
Until recently, the front springs of the automobile had to be stiff to keep the axle and front wheels in line. If one set of springs is stiffer than the other set, the stiff set will bounce harder and faster. We can see that this unequal springing, stiff springs in front and soft springs in rear, causes pitching when the wheels strike a bump. The traced line shows this clearly. The only way to eliminate this unequal springing and make the front springs soft is to give them only one job to perform, the job of absorbing bumps. Suppose we replace the bouncing axle with a rigid, immovable beam. Now the wheels can be fastened to the beam by 2 parallel swinging arms. The wheel is pivoted so that even when the arms are tilted by a jolt or bump, the wheel remains vertical and in perfect alignment. And so now, in place of a stiff spring, we can use a soft spiral spring to absorb the jolts and level out the bumps. Since the rigid beam and the swinging arms keep the front wheels in line, there is only one job left for our springs to do. With both front and rear springs equally soft, the platform is held in balance. But now that the front and rear springs are soft, we have another problem. Springs that are soft enough to level out the bumps will compress too rapidly under a heavy shock. And springs that are soft enough to absorb small shocks have a tendency to continue bouncing after they have been compressed or stretched. So to help the springs absorb heavy shocks, we can slow down their action by means of shock absorbers. The shock absorber acts like a brake in delaying the movement of the spring, and it prevents bouncing when the spring is compressed and then released. We can make the severest kind of test to see whether we have a method that will really iron out the ups and downs. We'll use a lot more bumps of different sizes, and we'll run them under our wheels at full speed. Now watch the traced line. The traced line seems to be pretty smooth. Let's watch through the slow motion camera and see just what's happening. No more pitching, and the soft springs with their shock absorbers spread out the effect of any bumps that they can't completely absorb. Of course, in actual practice, where strength and safety are of maximum importance, engineers have made use of these same bump-absorbing, road-leveling principles with a much stronger and more durable construction. The front wheel is pivoted so that it can be steered in any direction and is mounted on a strong, upright arm. The upright arm is fastened to the rigid, immovable crossbeam by means of two parallel swinging arms. The swinging arms and the rigid crossbeam do all the work of keeping the wheels in perfect alignment. So the genuine soft knee action spring has only one job to do: cushion the bumps. A double action shock absorber controls both the compressing and stretching of the spring as it absorbs heavy jolts. This combination of soft cushioning springs together with positive double action control on the front wheels is balanced at the rear wheels by equally soft springs with the same type of double action shock absorbers for control. With soft, balanced springing held under positive double control, the smoothing and leveling of roads is done by the motor car itself. The pitching and the ups and downs are eliminated. Here is a real test on a full-size scale. That pipe sticking up from the top of the car is a giant tracing pen. The sky itself will be our moving strip of tracing paper. And this tank of skywriting smoke will take the place of ink. The car rides smoothly over the waves while the wheels do all of the pounding. Watch the traced line. And so, the pain in the neck has been taken out of ordinary driving, giving a truly level ride over any bumps on city streets or on country roads. Strange as it may seem, ice skaters do not skate on ice. Even the smoothest ice isn't slippery enough for that. Ice must be lubricated before anything will slide on it. The skates really glide over a thin film of water under the skate. Here's what really happens. The blade of the skate cuts a groove, and the pressure melts enough ice to cover the groove with water. The thin film of water between the skate and the ice acts as a lubricant on which the blade can slide easily. A lubricant is something that makes things slippery. Water is sometimes used for lubrication.
especially where it can be supplied in large quantities. It takes a lot of water to keep this seagoing roller coaster from sticking to the chute. In some boats, a steady flow of water from the outside lubricates the shaft, which carries power from the engine to the propeller. However, water has disadvantages as a lubricant because it won't stay where it is needed. It pulls apart too easily, and it won't keep its film between moving surfaces. When the surfaces are squeezed together with enough pressure, the water is squeezed out. But there are better lubricants than water. When a sticking bureau drawer is stubborn and bulky, we can make it slippery with a little soap so that it will work easily. For the launching of a liner, tons of tallow or hard grease are used to make a smooth, slippery path. A simple experiment shows the effect of a lubricant. We use a block of metal polished to an even finish and a metal incline as smooth as glass. Without lubrication, the block will not slip. The two metal surfaces are in actual contact. However, if we lubricate the same surfaces, keep them apart with oil, the block will slide of its own weight. Here, magnified thousands of times, with the help of microphotography, we can see what happens when a metal surface glides over another surface of metal riding on a film of oil. Oil is a good lubricant because under high or low temperatures, it keeps an unbroken film to hold sliding surfaces apart, and it won't evaporate. Oil is liquid enough to get into small openings between closely fitting parts. Oil is thick enough to form a cushion that stays where it is needed, and it is elastic enough to make a film under pressure. A small flywheel bearing shows why it is necessary to use a good lubricant. We first remove all the grease or oil. When we spin the wheel, the metal surfaces rub against each other. Without oil, they grow hot. The soft bearing metal is melted. Friction binds the moving parts together, and soon the flywheel will stop. Without the protection of oil, both surfaces are ruined. There are three general ways of circulating a supply of lubricating oil to the parts of a machine. We can arrange a bath of oil so that moving parts can splash into it for lubrication. We can provide a supply of oil on a higher level so that it will trickle down through a system of tubing onto the moving parts. The force of gravity furnishes the power to carry a steady flow of lubricant where it is needed. If we want an extra amount of lubrication, we can force a stream under pressure directly onto the sliding surfaces. By controlling the pressure, we can control the lubrication for different speeds. There are many moving parts and many types of moving surfaces in the automobile engine. Consequently, the engines in our cars today use all three methods of lubrication to provide for the wide range of speeds and loads. The heart of the lubrication system is the oil pump. In the oil pump, the two revolving gears create a suction as the teeth move apart. This suction draws oil from the storage reservoir or oil pan. The gear teeth carry the oil around as they revolve, and then, as they mesh together, force it to the engine parts. Each gear tooth sends a strong spurt of oil, and at normal engine speeds, the result is a steady, smooth flow. In the modern engine, the main bearings carry the load of the crankshaft as it whirls at hundreds of revolutions each minute, and plenty of lubrication is needed. To get this lubrication, a constant stream of oil is pumped under pressure directly into the main bearings. The camshaft has the job of opening and closing the valves and needs an elastic cushion to protect it from friction. The oil flows through tubes to the bearings which carry the camshaft, and more oil flows out through a nozzle onto the timing gears which drive the camshaft. To keep the valves in smooth operation, oil is pumped up into the valve mechanism. A special method is used to lubricate the connecting rods. A high-pressure stream of oil is forced through nozzles in the base of the engine, and each jet of oil is accurately aimed to strike a scoop or dipper on the bottom of a connecting rod. The oil is forced up into the connecting rod bearing by the scoop-like action of the dipper as it strikes the jet. In scooping up water, a locomotive uses the same principle. A special motion picture camera equipped with what is called a stroboscope lets us see the action of the dipper on a crankshaft that is actually revolving at a speed of 3,600 times every minute. There is a hole in the bottom of the connecting rod through which the oil passes from the dipper into the bearing. At high engine speeds, the oil enters the dipper at the rate of 120 miles an hour. The barrel shape of the dipper picks up less oil at low speeds than at high speeds. And as the connecting rod splashes into the trough, it throws a spray of oil over the cylinder walls. This spray of oil forms a smooth film to lubricate the speeding piston as it slides up and down in the cylinder. A special ring on the piston controls the amount of this film. The excess oil is scraped off and carried through holes in the side of the piston to furnish the main lubrication for the piston pin. A steady stream of oil flows through the engine, bathing the crankshaft, the camshaft, valves, and pistons and connecting rods, covering all the moving parts with a protecting film. The modern engine uses the same oil over and over again, 4 times a minute at normal speed. In order to do this, it must be cleaned and cooled. Each time the oil passes through the engine, it is filtered so that dirt and impurities can be kept from the polished surfaces. The oil is cooled in the bottom of the engine and allowed to rest in the oil pan. Efficient crankcase ventilation removes hot, corrosive gases so they cannot contaminate the pure oil. A tremendous stream of cooling, cushioning lubricant is pumped through the engine. By connecting a hose to the pump and arranging a return pipe, we can see the amount of oil that flows from the pump each minute that the engine is in operation, enough to fill a bathtub in 3 minutes. Closely fitting, highly polished parts, moving at high speeds, year in and year out, demand an adequate supply of good, clean oil to protect them from friction and wear, to give power, economy, smooth, silent operation, and long life, with every part riding a film of oil.
You guys want one more? I got one more, and then we'll start.
Over the brink of Niagara Falls, 1,000,000 tons of water pour, and 212 feet below, the mighty torrent falls against the blades of huge turbines, creating horsepower to light 275 cities, towns, and villages, and run the motors of thousands of factories. This ability of liquids to transmit power comes from one important natural law. You can't push a liquid together or compress it into a smaller space than it already occupies. If you take a piece of ordinary pipe and fill it with liquid and put a plunger at both ends, Any blow on one plunger sends the other plunger flying out. Liquids can't be compressed, so here's what happens inside. The power of your blow is transferred to the other plunger by hydraulic transfer of power. This is the simplest kind of hydraulic system. Bending the pipe doesn't affect this transfer of power at all. It goes around corners just the same. When one plunger is pushed down an inch, the other end comes up an inch, and a pound of pressure exerted at one end is transmitted to the other. Suppose we have 4 pistons at one end and only 1 at the other. Now, when the single piston travels 4 inches, each of the 4 at the other end travels 1 inch. A large piston of the same area behaves the same as 4 smaller pistons. Moving the small piston down 4 inches carries the large piston up only 1 inch, but with 4 times the force applied. This is the principle on which commercial and industrial hydraulic systems are based. Down in Dixie, billions of pounds of cotton are baled up every year by the power of hydraulic presses. With Uncle Sam's long-range guns, not only are power and reliability needed, but minute precision is required. Precision that aims these mammoth guns within limits of 1/1000th of an inch, hydraulically. The hydraulic stage works by the same method and times its cue right on the nose with the reliability of an old-time actor. This model is a hydraulic system which shows how the hydraulic press multiplies power. This is the pump. This tube holds the liquid through which the power is transmitted, and these 4 cylinders at the other end receive the power. The movement of the large piston compresses or crushes anything put in the press. The hydraulic stage operates with the same reliable elements. The accurate hydraulic transmission screw in the coast defense guns is more complicated, but in principle, it is the same as the lift and the press. In any hydraulic system, regardless of how many cylinders are attached to a master cylinder, each of the small cylinders receives the same amount of pressure and moves the same distance as the others. This principle is used in the latest application of hydraulic transfer of power, stopping the modern motor car. The master cylinder is placed under the brake pedal, and the power cylinder is put in the brake of each wheel. Now, when you press down on the brake pedal, each of the 4 power pistons is forced an equal distance against the brake shoes, pressing them uniformly against the brake drum. The shoes are hinged in such a way that the entire lining contacts the drum throughout the life of the car. No grab at the top or bottom, smooth, even taking hold by the entire shoe surface. These are the brake shoes of a new car. Let's paint this pair black and examine the wear they take. Note the even grip on the shoes in the first 20 miles. Perfect contact at 5,000 miles. And after 20,000 miles, uniform wear, and still good for many more. For durability, the linings must be hard, uniform, and unaffected by moisture. All else being equal, long life and effectiveness of the brake depend on the amount of material contacting the drum. Brake drums must be wide and large in diameter, smoothly machined on the inside. A car that takes 90 horsepower to go from a dead start to 60 miles per hour in 20 seconds can stop in 4 seconds, but it takes 450 horsepower in the brakes. The final safety and control of the car depends on the construction of the brake itself. It is the brake itself that stops the car, not the hydraulic control. Perfected hydraulic control transmits the power from the foot pedal to the brake itself and gives you the sure, quick-stopping safety of the modern automobile.
All right. There's plenty of those videos, guys. They're around. The hydraulic one, and the wheel, and the spokes. Yeah, we got plenty of those. I like watching them during Space News, or during while I'm eating my lunch. They're pretty cool, huh? You can learn a lot from those. The suspension one is really good. The one about the suspension is that is to this day the best explanation of how suspension on a car works that I've ever seen. Yeah, no bullcrap, dude. That's why I like those videos. I try to make sure that I explain things kind of like that. Now, time for the quiz. If you fail, you get banned. Is there a specific channel on YouTube that has all these? Publicresource.org, I think, is on there. That video went right to the point. And the guy is speaking in a very straightforward tone. I don't know why he's putting emphasis on wheel, but he is. Yeah, exactly. Yeah, Jason, exactly. That's right. We need to practice things, and we need more spokes. The animated one about atmospheric reentry. Yeah. Dr. Peter parameter. The thermokinetic displacement through a plastic nonlinear density at random velocities and angles, which can just be summed up by this formula here. You're not native English, and it helps. Yeah, Steam, I speak like that on stream, dude. This is how I talk on stream. It's like a modern version of that. I do that on purpose. For people that don't speak English as their first language. When I'm explaining things, I explain them very clear and concise. And I try not to talk really, really fast like this. I do that for the people overseas. I've always done that. How do I normally speak then? I don't know. Been playing 1x timescale KSP. Yeah, there you go, Midge, right? What's your natural accent? Just curious. I don't know. I can't... Can you speak other languages? Badly. We should go full Brahmin for a whole stream one day. I can't... If I try to talk normally, it won't sound right. That's the thing. I'm English even when I speak other languages. Midge, I don't think anybody understands what that means, but I do. I don't know. It's tough. Like, you put me on the spot like that. It's just... It comes through at times. Like the other day we were talking about Steam and how Steam works, right? And I was talking about water heaters, and I was saying, like, you remember that episode of Mythbusters where they had the water heater and they shot the water heater through the roof of the mock-up house? Oh yeah, we were talking about Arca. I said water heater. Yeah, that's normal voice. Can you go to do that Deep Morgan Freeman voice again? Can you go to another baseball match? Baseball match. Don't call baseball's match. You call it a baseball game. Baseball match is weird. That's not right.
Discovery.
It is right, but Rev, if you're ever over here, call it a baseball game. Don't call it a match. Match is like tennis or soccer. You're into character now. In Twitch, it's difficult to switch back and forth. Sometimes I say fire like fire. Yeah. Cat King, 26-month resub, 25 plus 1. I like baseball match more. Baseball match will let somebody know you're not American very, very quickly, or you don't understand baseball at all. Football session, yep. Mm-hmm. Gotta give it to him. This was epic. Mute it and watch.
There goes the rear wing open. Hamilton, he's a long way back. It'll be a big...
Yeah, they cheating. Rounders, yeah. I have a neutral accent, but I get tired of drunk by Southern John. Yeah. Dish, I have, like... I don't hear it when I talk, but there is a hint of Boston accent there. I don't hear it when I speak, though. But I remember, like, I went to TwitchCon one time, and I was talking with a bunch of other streamers about accents, and I'm like, yeah, I don't have an accent. And they're like, oh, yeah, you do. And I'm like, what are you talking about? They're like, oh, yeah, you have an accent. I'm like, I don't know what you're talking. I don't know what you mean. Speaking of accents, you saw Bill Nelson speak today, and I have to ask you, Vulcan, did he fall off of a log into a giant vat of pudding? Did you know that NASA is the #1 place to work for federal employees out of any establishment? Do you know why? It's because we have pudding. All right, we have the best pudding. We have the tapioca pudding was voted best here. That's what I'm trying to tell you. Not gonna lie, I barely hear any Boston from you. Yeah, that's what I cover it up, but I don't do it on purpose. I do it because I'm trying to speak in a very straightforward announcer voice. Comes out a little bit, but not often. Most of the time you sound like you're from the Midwest. Yeah, strange. We are making pudding to inspire the Artemis generation. My personal favorite is tapioca. Pudding is used as lubrication. Yeah, right. What's the Discord? Huh? Just exclamation point Discord, Midge. I already told you 7 months of litigation stopped us from serving chocolate pudding. Facts. Yeah, I don't know. I don't know how, like, I guess my regular voice would just be talking like this. Yeah. I can't, if I try to do it on stream, it's not gonna sound right. Strange. Shame on you for covering up your annoying ass accent. Yeah, Vola, because I want to sit here and listen to these friggin' fools give me crap over it all friggin' day. No, screw that, man. I'll make sure to freaking not drop the eyes around here, okay? Because you know good and well, if it was, everyone would be like, "Where are you from?" Have Brimo record a random conversation. Or yeah. You just got smart pack. You know how that commercial would end in real life, geek? Hey, who's this guy that parked too close to my freaking car? What is this? What is this? You parked too close. Now I can't even get in. Oh, great. You got smart pack. You know what I got? Guy? I got smart key. Here. Oh, look. I smart keyed your friggin' paint job. Don't park your car so close to mine. Frickin' moron. I want to go to Boston and ask the locals to say car keys. Yeah. Not a good idea. Oh, look, oh, great. You parked so close to my car, your car automatically parks there. Good job. Good job there, Ace. How the heck are you supposed to get out, moron? Do you also drink coffee while walking your dog? No, coffee while walking your dog. See, even then, that's still over-exaggerated. That's not how I talk. That's you. That's how you talk. I say, and dude, I made it a thing to not say this on stream anymore. From, I pronounce it F-R-U-M, which is leftover Boston accent. And then room, I say rum. Go over to the rum. Yeah. My dad's texting me about how much he hates Lewis Hamilton. Yes! Yeah, I just saw it. Bunch of bull crap. Yeah, no, he doesn't like him either. He's like, they're cheating. They're friggin' cheating. I'm like, yep. Is that not how you pronounce from? No, F-R-U, from. Room. Yeah. Do you say no. Medford. See, it's like a Medford. Medford. How I would say it on stream, though, Villa, is Medford. There's a town near me. Yeah, no, see? Oh, boy. Remember what Ferrari did during the 2019 season? Yeah, Alex. Did the FIA apologize for them, too? Oh, they didn't mean to have the DRS open all the way. Merde. Merde coming from your mouth. Oh, hey, RT. Bonjour. I wasn't saying bad words. Bad words! Merde. Did Crew 3 make it? They're up at the station. All right, let's get into space news. A friend sent me this, and all I see is big modern Soyuz. What's that? Oh, this is great. I like it. You know, let's start space news with that. I see what this is supposed to be. That's cool. Hey, got freaking smart pack. You know what I have? I have smart key. Oh, I smart keyed your car. That's funny. Modern Soyuz, yeah, right? You ever stared at it? Marveled at its beauty, its genius? That's actually pretty cool. Don't forget that I have a video from you. What if I don't want to show it, Vulcan? I'm just kidding. I'll show it right now. So, yeah, this morning, Starlink went off, which is pretty cool. I tried to wake up, and I woke up just a little bit too late. That whole, you know, that whole getting 2 hours of sleep thing, yeah, that didn't work. You know, you think I would have learned that by now, but I like the thick Boston accent. It sounds like a ranting bald head, but that's because I only know how Bill Burr talks. See, Bill Burr has that hint of Boston. That's his accent is not someone that's from the city, but from outside the city, like kind of where I'm from. Yeah. Also, Vid, I forgot to submit for Space News 4 days ago. Okay. Okay. Here. So, it was actually a pretty beautiful launch this morning. Here, check this out. This is coming from good old Space Scout. Let's see what we got here. Vulcan, what's up? Hint of Boston. New fragrance from L'Oreal. Yep. Need to go to 4 minutes, 40 seconds. Okay. Yeah, there's a little bit of a marine layer, huh? Oh, ITL Causeway. Ooh, you're getting fancy. Oh, so fancy. Do you put your pinky out when you talk? Taste of matured, only the ideal Causeway will do. Yeah, I thought you might like that. Of course, man. Can I just...
There you go.
In real life is like nothing you've ever heard. It sounds like thunder, like the clap from thunder. You ever know, like, you ever been in a thunderstorm and have, like, there's lightning that's far away, and then there's thunder and lightning that happens that's like within a mile of you, and it sounds like a clap noise instead of like a rumble. That's the noise that rockets make, but constant. It's just that constant noise. Being there is amazing. Yeah, exactly. You feel the pressure shift right here, WD-40. Dude, I was thinking about your idea. We should do that. We should do that. I have to talk to some people about that though. Like, yeah, gotta figure some things out. But which idea? I have a lot of ideas. Okay, best sensation ever is watching 40 launches from the VIF, only 1 mile away. CN, do you think that like we could stream a launch from? No, we can't. We can't broadcast from there. Nope. Never mind. Yeah, they probably wouldn't like that. But if we were hard-lined in, the VIF got good internet? I'll watch a rocket launch from there. Yeah, WD, I agree. But WD, Vulcan is also would probably be someone we want to bring in on this project. But Vulcan and let's do it right, you know? I wonder if we could. No, Kelly, it's about broadcasting. No wireless transmission near the rocket. No, that's a big no-no. You don't want to like broadcast on a frequency or something and have it jive up the rocket's avionics. Yeah, someone would get mad. So yeah, something like that, drummer. Something like that. Yeah. Yeah. I wonder if we could do that. Oh, dude, I'd watch them. I've watched rockets go off from that close. Not go off. I watched the Falcon. Me and a couple of other guys. I've told this story on stream a couple of times. Me and a couple of other guys watched a rocket, and we couldn't stream it. Obviously, we watched the Falcon 9 static fire from like 3/4 of a mile away on the ITL causeway. We were very close. Very close. And, yeah. You don't need to know how or why I got there. We weren't breaking any laws. The security guys were there right there with us. But, they are loud. They are very loud. Yeah, we didn't sneak in or anything. Don't try that. You'll get shot. Yeah, don't do that. Don't screw around with that. They'll get mad at you. Like, very mad at you. I don't know if they let you stream or even photograph that close, unfortunately. That brings in some issues for 45th or their liability. Yeah. Isn't that need hearing protection close? Nah. It's about 1 kilometer away, Kamer. 3/4 of a mile is close to about 1 kilometer. It's... Well, yeah, it's about right. It was loud, but it was only a static fire. It was only for a second, so, yeah. Yeah, we, don't get me wrong, we were there with the security teams and everything, like, we had the passes and everything to be there. We, like, don't get me wrong, we didn't sneak on or anything, but yeah. Mid-Atlantic is about 2 miles away, Joe. That's still really freaking close. And that's why Antares seems louder than everything, dude. That, and it's got 2 screaming RD-191s underneath it. Or just a single... Or it's an RD-181 that's 2 RD-190s conjoined at the hip, basically. But, yeah. It's a great noise. Strange. It's like nothing you've ever heard. Yeah. The media side is relatively... Yeah, so WD, yeah, we'll see what we can do. Yeah, that would be good. I never understood the difference between... I never understood the 181 difference from the 190s. And it's like the LR87 on a Titan. It's the same thing. Same exact kind of naming convention. The LR87 is technically 2 rocket motors. But the 2 rocket motors work as a pair. And an LR87 is 2 of those rocket motors working as a pair. If there was a single one, it's a different rocket motor. It's the same thing. On Antares, it's 2 RD-191s, or RD-190, or something derived from an RD-190, working as a pair. And those 2 RD-190s paired together is an RD-181. I.e., 2 power packs, 2 nozzles, right? An RD-190 is a 1 power pack, 1 nozzle, and an RD-180 is 1 power pack, 2 nozzles. Right? Like, that's, yeah, Russian rocket motors. They make, I mean, great first stage engines, to be honest with you. Really good. Skyline's going to be insane. Yep. That's right. Yep. Yeah, you got it, CN. I mean, I don't need to tell you that. You knew that already. Starship presentation is on Wednesday? What is this, Limprod? Eventbrite. What is this? Join the National Academies to discuss the ongoing efforts in space exploration, future directions for NASA, and advances in fusion. Oh boy. Hear about SpaceX Starship program directly from Elon Musk, 6 to 6:30 on Wednesday, November 17th. Well, we're going to watch that. Oh, Dan Golden's going to be there. Interesting. Is this space news or space chat? Yeah. So Starlink went off this morning. That was, everything seemed good with the launch. These are the new generation of satellites, but let's see. Let me look. I gotta go find some stuff. I gotta find more things. The Astra launch did get postponed. It's on the 19th now. It was supposed to be tonight, but it's scrubbed. Electron is also a little ways out from what I understand. Oh, okay, WD. Right on. I got that. Let's see. Yeah, so here's the thing from Astra. Astra has a really nice picture here. Starlink 4.1 launch was 35 kilogram heavier than the previous launches, even though it had less satellites. This is due to them being the version 1.5 sats with the laser links. Cool. Okay. Let's see. Yep, there's Launch Vehicle 7. Oh, they repaired the fence. Oh, that's nice. So they moved out. They did some additional operations down they're up in Kodiak there. Is that why they launched fewer, or they just didn't need to do a full batch? I'm not exactly sure. To be honest, I missed the launch. I slept through it. So, here.
Deploy confirmed.
I do have SpaceX has the deployment confirmed. Here, take a look. Hey, there you go. They launched fewer due to the satellites being heavier. So, how many were on this, Thomas? 50 something? There wasn't 60. 60 was on the previous one, right? 53. Got it. They labeled a range as 55 when I'm actually 53. Cool. EJ missing a SpaceX launch. Elfish, I'm not happy about that. I spent way too much time last night racing or practicing. We did practice for like 2 hours. Oh, and I still ended up crashing the car. I just was too tired. I tried to wake up for this launch on Friday morning, and I woke up at 7, and I ended up staying up from 7 a.m. till basically 3 a.m. the next day. And then I tried to get 2 hours of sleep, and body said no. Don't blame this on Friday night racing. No, it's more them scrubbing. The scrubs really screw up my schedule, Roblox, especially if it's... Oop, I unmuted the audio. Especially if it's on Fridays or Saturdays. Scrub, because I have to be careful, and I have to make sure, because you guys are showing up. I don't want to, you know, I don't want to, you know, have everybody show up for racing and be like, nope, can't do it, rocket launch, you know? I don't like that. So I got to be careful. So this was supposed to be on Friday, so, you know, it was fine, right? And then they scrubbed, and I had already tried to jump my sleep schedule for Friday. Like, I was up from 7 a.m., and then maybe I slept for like an hour after that. And then I was up, and then I started the stream at 11 because of the SN20 static fire. So I streamed from like 11 to like 3 in the morning with a 2-hour break in the well, no, it wasn't really a 2-hour break. It was an hour break. Oh, boy. Yeah, and then for some reason I thought it was a good idea to get 2 hours of sleep and wake up. And I almost did it. I woke up at 7:30. Like, just, like, oh crap, the rocket launch, you know? DM'd you on Twitter with a highlight of the capsule returning to port if you wanted to show it. Yeah, sure. So, like, I ended the stream early Thursday night so I could get enough sleep for the rocket launch and then stream the whole day, and that didn't happen. Yeah, they got all messed up. And yeah, I'm bumming, man. I'm bummed out. You know why I'm bummed out? That's the first SpaceX launch I've missed since 2013. Seriously, I've never missed one. Which I'm really upset about. I've never missed one. I stayed up and slept through the day. Does that mean spaceflight is routine now? I don't know. I also shared my supersonic retro propulsion with you just so you can say it. Yeah, alright. Okay. You were able to catch the capsule coming back this morning. Alright. Well, here's an ad because, you know, I'm interested in Billie Eilish Twitch. That's good. You know, there's an ad for this Twitter VOD. That's good. Don't feel too bad about it. I missed it too because I didn't want to stay up. Yeah. I'm bumming, man. I don't like saying I'm gonna be somewhere and then not be there. You know, it's very, very frustrating. But anyway, here. This video is coming from Dr. WD40, Twitch streaming buddy of mine. Here you go. IRL Twitch streaming buddy of mine. Hey.
The Endeavor capsule, the Dragon capsule that returned.
My guy, dude.
During Crew 2. So they'll be coming back, restoring it, and then sending up for, I guess, would be Crew 4 would be its next mission, because Crew 3 just launched the other day.
Might not want to play my audio in case I said something wrong. Okay. Yeah, no, this is fine, dude. It's all good, man. I'm not you're not an expert, bro. Like, you don't live and breathe this stuff. But WD-40, if we're gonna go talk about birds, man, I ain't gonna question your judgment. You know what I'm saying? Like, you know, we talk about you put stuff in your wheelhouse. I'm gonna be like, yeah, no, you're right. You know? Dude, look at that thing. This is the capsule coming back. That's the Crew 2 capsule. Made a guess they're on Crew 4. That's not a bad assumption. I think here I'll fact check myself here. Dragon 2 capsule. Let's take a look. Dude, this is... we went digging through Wikipedia yesterday, and I get it, it's Wikipedia, but it actually is pretty freaking good. Check this out. So, Endeavour was on Crew 2, and I think that C211 is scheduled for 4. I think Crew 2 would be scheduled for 5, I think. I'm not sure, because SpaceX is trying to get a rotation of capsules. And it's just like the shuttles. You know, when the shuttle was first flying, it was just Columbia. Columbia flew the first 4, I think it was the first, like, 9 missions or something. Challenger flew the 10th. And then Challenger flew 10 missions between the 10th shuttle flight and the 25th shuttle flight. And, like, Columbia flew a couple of them. And then Discovery and Atlantis flew, like, 1 or 2. And then Challenger, unfortunately, that happened. And, and then Discovery returned to flight from there. And then it was just Discovery, Atlantis, Endeavour, Columbia, Discovery, Atlantis, Endeavour, Columbia. Like, they just kind of kept it rotating, like a pitching rotation almost. I think SpaceX is trying to do that with the capsules. So I think that right now you're going to see Endeavour fly more, right? And then it'll be a lot bigger of a rotation once they get more capsules. First five Challenger flight was SES-6. Yeah, that was off the top of my head, but the point still stands, Vulcan. Yeah. Oh, nice. But yeah, here, let's keep watching. Let's see. Yeah, they are rotating stuff out. So Crew 4 was a good assumption, man. You were fine. Yeah, but look at that thing. Look at that sucker. Oh, new Starlink antenna. Cool. Yeah, see? Look. That really drives the point home how big that capsule is. It's a big capsule because it's, like I said, fellas, it's got a service module jammed up the back. Dragon is a service module and a crew tank that flies as one. And that's why it's so oblong. Look at that thing. Yeah, she's a bit toasty. It's toasty marshmallow. We can make a good s'more there. Yeah. Oh, this is great, dude. Great footage. What's Axiom? Private a spaceflight company that wants to make commercial space stations. Look at this guy. Look at that dude. Look at this dude. Just enjoying life right there. I'm sorry, that guy's just like, wow, this is pretty neat. That guy's having a freaking existential moment over there. Did you guys see that? Watch the dude on the left with the multicolored shirt. Just walks out. Yeah, everything's kind of cool. This is pretty sweet. Oh, man. Wow. Hey. This doesn't suck. This is great. Look at this dude. Look at this dude. I mentioned him in my stream too. Yeah, that guy's just like, man, this is great. How much service module gear is in the trunk? Solar panels and radiators, granted, and that's it. The trunk is just a hollow cylinder, dude. That's it. It's literally a funnel. Well, not a funnel. It's just a hollow cylinder. Most of the service module's main components are there. Inside of that. Inside the capsule. As then he's thinking I get paid to do this. That certainly looks like that kind of face, huh? Yeah, this is great footage, man. Picked up from the Gulf of Mexico. That's right. They can use the trunk as storage, though, right? It can be used to take small components that aren't like small and pressurized things. Yeah, sure, absolutely. How much weight would a fuel tank and a small engine add? So, giving it a more dedicated surface propulsion system? I don't know. Yeah, those things get a little messed up, huh, Thomas? Huh? Jeez. Has Dragon brought up cargo in the crew trunk yet? Not with crew aboard, boring, no. Yeah, dude, look at how big it is. I remember standing when I toured SpaceX's headquarters. I remember standing next to a Dragon 1 and thinking it was big. Dragon 2 is bigger than that. They can't do to launch escape system requirements for crew missions. Yeah, she's a biggin. Orion's bigger than that, fellas. Yeah, Orion's way bigger than that. Whatever happened to the Dragon XL variant we heard about like once, maybe? Not sure. Aces, I haven't even heard anything about that thing yet. What outer material does Dragon have that's heat resistant? Not sure what the outside of that capsule's made out of, dude. I know the heat shield is phenolic impregnated carbon ablator, but I don't know. I don't know what the outside of it is. Yeah, I haven't heard anything about Dragon XL. I have what I think is going on. And then I have what I think is going on, and then that, I mean, I don't know. That's like based off of nothing. Oh, interesting, Vulcan. Yeah, I see what you said there. What was your SN10 reaction? Oh, it exploded. Did they use a special paint too? I don't know if it's a paint. I don't know if it's paint. It's some kind of thermal protection system. Dragon XL is still happening. Yeah. It's been very quiet, Thomas, about that though. I was starting to think that Starship might replace Dragon XL's contract. That's what I said. That's what I was talking. That's what I meant. Like, I think that might happen. But anyway, here's another video coming from WD-40. I think you guys would appreciate it because supersonic retro propulsion. Yeah, that really drives the point home, WD, of Falcon 9's exhaust gases being used as a heat shield. This footage, though. Alright. That's really good footage, man. Yeah, there you go. How'd you get this? Link it? No, this is not public. This is not public. This is WD shooting footage, shooting his own footage. You don't get the link for this. Wow. Yeah, look at that. Freaking heat shield, man. See it? It's pushing the plasma out of the way. That still blows my mind. Here it is. I mean, this is actually, dude, actually really good footage to show. This was from your house about 40 miles south, like last year. Wow. Finally, a worthy opponent. Yeah. Wow. That's something else, man. It's an amazing thing to see, huh? Crazy. All right. Cool. Anyway, WD, thank you for showing me that. I really appreciate it. We'll talk about things later, man. It's literally a perfect shot. Yep, absolutely. WD posted the link in the chat. What if rocket engine equals heat shield? So much awesome engineering. It's a design that NASA came up with, Rizik. Supersonic retropropulsion was pioneered by NASA. And it was... they never intended to do supersonic retropropulsion on Earth. NASA applied that concept, or came up with that concept for landing big payloads on Mars, believe it or not. Yeah, that's where that comes from. The latest pictures of the Checkmate fighter just show us how big it is. Oh. What is that, a Pac 50? It's a Pac 50 and a Sukhoi 57. Interesting looking planes. Yeah, it was designed for landing heavy payloads on Mars. What is this? So this is the drive, the war zone. I can't believe there's like sites that just show this. Huh. 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 Who took these? Ruprecht. Look at the Pac 50 though. Nice. Huh. Huh? Yeah. That's a cool plane. Yeah, that's cool. This one is throwing me, dude, because it has no horizontal stabilizers. That's very, I mean, because it has the control surfaces up there. Undersea tunnel exploration complete. Exploratory tunnel hits open ocean just to the right of the northmost pier. Okay, Megas. Do you see the inlets under the stabilizers on the Su-57? Yeah. Yeah. Interesting. Some next level stuff, man. Alright. What else? Forge, what did you want me to see? Yeah, here's some footage that's from SpaceX here. This is CRS-11. Oh man, old SpaceX UI. It looks so strange now. When is the next Hunt the Streamer? I'm not sure. The Dragon XL contract had a modification in the description. The purpose of this contract modification is to order special task and study SX-30721 private crew compartment PCC and waste management system feasibility study. Yeah, Thomas, I think that Dragon XL will end up being Starship. I'm pretty dang sure. Why don't they show this? Well, the booster doesn't always land near a camera. Oh, that's so rad. Check Discord. We have a Discord event for it. December 5th. Thank you. Yeah, that's supersonic retropropulsion. There it is. I don't know why they don't talk more about it, but they never talk about it on the cast. There's probably a good reason. It's probably because they can't explain it fast enough. Okay, they cheat with tracking software. That's not fair. I'm on a tripod, yeah. Unbelievable. That's cool, man. Yeah, supersonic retro... Guys, look at it this way. If I know how supersonic retro propulsion works, it's not ITAR. Let's put it to you like that. Because you almost always have it muted at that point. Lol. Yeah. Because they don't talk about it. Probably just because the audience won't be like, wait, what now? Yeah, that's true. That's true. They probably, yeah, it's probably too complicated of a concept for the normies. I still like watching the footage of the one that had the grid fin lock up and hit the ocean. Yep. Yep. It's funny. They do say that the entry burn is used to slow the vehicle down and protect the booster during entry, so simple enough, I guess. Yeah. Towing the booster into port was hilarious. That was cool, man. Yeah. Okay.
Discovery, go at throttle up.
Kickning, 14-month resub. Thanks, man. All right, guys, let's go see what NASA spaceflight's up to. I'll be honest with you, fellas. I'm super freaking tired. I tried to push myself too far and it didn't work. So I'm all messed up. The rocket launches, man. You know, if one doesn't happen when I'm like, dude, I stream like at least 60% of like every week or something, man. Like out of the total hours, like there's like well over a 50-50 chance of it being during a stream. And when they're not during a stream, oh man, does it really messes me up. The best teachers can simplify the material without hurting relevancy and can do it quickly. Yep. Nap after space news. Nah, I want to get that stuff done in KSP. Let's see if there's a Starship update. There isn't. They haven't posted the Starship video. There's the static fire stuff if you guys want to see that. Here, let's check this out. Yeah, okay, here we go. We got a video coming from NSF here. Let's see what we got. NASA Johnson posted new renders of Gateway with Dragon XL docked. Oh, wow. That's neat. Interesting. Okay, so, well, your renders probably tell you that what I was thinking is not correct, so. Could this shot be more lined up? All right, here, I'm gonna go over there. Yeah, boy, so yesterday SN20 fired, so that was 6 pre-burners from the 3 vacuum and the 3 sea level engines right there. And then, after this, they did a full 6-engine static fire. The first time a Starship was lit up with all 6 engines. Interesting. Forge. Sorry to miss Minecraft this morning. Had stuff. Dude, don't worry about it. It's okay. That's a pre-burner test. Pre-burner test is the fuel delivery system for the rocket motors, basically. They're just... It's starting the fuel pumps without starting the rocket engine. That's the very general way of saying it. Stage combustion cycle is not just a... When you have a full flow stage combustion cycle, it's not just starting the fuel pumps. They actually pre-ignite the fuel with a pre-burner and then put it into the rocket engine. What you're seeing there come out of this thing is the fuel-rich mixture that would be combusted inside of Raptor, inside of the main combustion chamber on Raptor, and then shot out the bottom as rocket exhaust. That's the fuel. That's the mixture that would have gone. That goes into the rocket engines before the rocket engines ignite it and shoot it out the bottom. Yeah. See. Okay. You can always tell something is burning fuel rich, especially if it's a petroleum or a hydrocarbon. And methane isn't a hydrocarbon, but it's close. It's CH4. You can always tell because of the black soot in the clouds. Watch. See how dark this is right here? Right there, right there, right there, right there, right there? This stuff, that's very fuel rich. Very fuel rich. See how, look at it. Even when the fire goes out, there's still unburnt fuel here. Or at least partially burned. It's the simplest hydrocarbon, yep. Yeah, look at that. Yeah, they have to roll coal. Exactly. Yep. Here, let's check the static fire. So check this out. Yeah, that's right, Catcher. Yeah, you ain't kidding. I thought it was the engine too, and I'm like, wait, that's coming from out my window. There's not. That was weird, man. What just happened? Literally right when SN20 in the video that we're watching, right when the engines went off, there was thunder outside. What the heck? That was weird, man. There we go, 6-engine firing right there. Pretty awesome. Let's see. These 25 speed replays from Mary are really good. 25%. It was an omen. Elon has the favor of Zeus. Dude, it started to... Not only did it shake a bunch of the ice off, but it started pulling the gas down. That thing made a vacuum very quickly. So when rocket engines fire, they usually with rockets around here, around the in the Western Hemisphere. I mean the Russians and a couple other people do it a little bit differently. But around here, you hold it on the pad for a second to make sure that the engine is working, and then you let it go. And in that time, the rocket engine is accelerating gases into the flame trench so ridiculously fast that it starts pulling air in. It starts pulling air down the flame trench. And you can see this, especially with the 25% speed. You see the frost come off, and then it starts to move down really quickly, and then they shut the engines off, and it stops. So see all the frost that comes off, and then it starts to go down, and then it just kind of stops there when they shut the engines off. You see that? Yeah. They made the 6 Raptor engines firing made a vacuum down there very quickly. It's a lot. That's indicative of a lot of thrust. Interesting thing to actually think about now that I'm kind of considering it. How much liftoff thrust does this thing have? Yeah, there were some tiles that fell off, Hunts. Just not as many as you might think. Now imagine 29. Yeah, exactly, right? So, what's each Raptor making? About 2,000 kilonewtons of thrust? How much does the Vectors make? Do we know? At least 1, at least 3, more than 6. Let's just say a Raptor makes 2,000 kilonewtons. That's 12 meganewtons from one starship right there. That's more than Falcon 9's first stage. That's more than Falcon 9's first stage. What's Falcon Heavy? 27 meganewtons, give or take. Merlin 1Ds make about 1,000 kilonewtons of thrust, from what I understand. Could it nearly SSTO this thing? Yeah, it's close. Starship could SSTO, but I don't think it would have enough fuel to land. Unless you filled the payload bay with fuel, and then maybe, in which case your payload volume for that ship that big is about the size of a shoebox. Yeah, freaking Delta V. Pain in the butt. Interesting. I didn't really consider that. Yeah, you need something that big just to make a small sat launcher if you want to make it reusable. Trey Brew, that's pretty crazy. X-33. Yeah, right, Rocket Guy? That's nuts. Yeah, Ray would be freaking screwed, dude. Man, look at it kick up the dust, dude. Did a freight train derail outside or something? Seriously. That shook the goddamn house. Like, that was a rumble there. It's just the landscapers. Did you like, dude, the floor shook. Assuming 2% payload mass, the X-33 weighing in at 129 metric tons would have been able to put 2,300 kilograms. So yeah, large vehicle, small payload. Yep. Damn. Hang on. I gotta go on Windy real quick. What is this? Oh, wow. That's a big storm that's coming. Oh. 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 Yeah, Dover is a little ways south of me, dudes. These lightning strikes aren't close. They're not close because they're rumbling. They're not crackling. Crackling is close. Huh. Yeah, that thunder just kept going, man. Like, it rumbled. It got louder over time. That's nuts, dude. Let me turn the amp on. We'll turn the amplifier on. Let's see if we can hear it. Fire up the lightning detector. You read my mind. Medway just got 4 strikes. Yeah, Devlin, that's a good ways south. Medway... Dover is pretty close to where I am, but it's not... It's two towns over. There's... Needham is in between. Where I am. Yeah, that's not... Yeah, that's a little ways south. All those lightning strikes. Okay. Time to play Ride the Lightning. You have a thunderstorm warning in effect. Yeah. Yeah, I heard. I heard about it. That's not thunder, that's the rocket. Tornado warnings around Providence. Yep. Yeah, we're about to get a lot of rain. But I didn't. You're going to get the same storm that hit me Thursday and Friday. It was a good 2-day blizzard with winds over 50 miles an hour. Nice. Lightning-based trends looking to head towards Newton directly. Oh boy, the power might go out. Yeah, I have a UPS though that should be able to withstand it. Actually, the last time the power went out, the UPS just carried everything over and all the lights stayed on in this room. And I totally didn't notice. It was out for like maybe 10 to 15 seconds. I heard the beeps from the power supply. I'm like, uh-oh, power surge. Nope, the power went out. You got like 3 inches of snow? Oh, yeah. The weather is about to be like, take a break. Yeah, maybe. How much time can it cover me? 45 minutes, depending. It's a big UPS. Yeah, about 45 minutes. If I don't do it, if the computers aren't using a lot of power. Streaming, probably less. You remember we were watching the stream was on. Sure. Yeah. I remember. Ugh, Kelly, I hate snow. Guessing the universal power supply is a surge protector built in or something. I know it's very odd. Yeah, of course. Yeah, they had mild damage. Let me take a look at that again. I want to see that one more time. So, fellas, Rocket Guy, if you're here, feel free to comment on this. I'm going to go ahead and say that it's pretty damn remarkable that SpaceX didn't have more of these tiles pop off, especially in the parts of the tank that were frosty. You could see that this was cold. Also, you could pretty blatantly see it from the static fires. the tiles seem to be, like, obviously you're missing tiles. Like, those tiles they never put back on. The ones that have the white backing blanket are the ones that fell. Like, you can see there's one that's slightly damaged right there. In a 6-engine static fire with cryogenic propellants. Yeah, Vasi, that's pretty dang impressive. A remarkable amount of these are still attached. That one fell off. There's a couple. That. There's. These are little nicks. And I'm not sure what those are from. Maybe it's from kicking up dust or something. That one popped off. That one's damaged. See, these tiles that get nicked up, that's no big deal. That's not a problem. It's the ones that pop out. That's a problem. Yeah, you're going to be... Yeah, those ones... The ones that get nicked up, that happens. Stuff hits the tiles. Like, you see all these little... Like, 1, 2... Some of these are damaged pretty badly. But a lot of them are popping off. A lot of them are popping off around the methane tank. Particularly where the methane tank is attached to the barrel segment. So this is where the top of the methane tank is. I see the most tiles are popped off in that area. And that's from other static fires. When the tank is cold, the tiles are getting closer due to the contraction of the tank under it. Yeah, maybe. I'm not sure if those have to do with temperature, but these ones up here, yeah, this would have been, I mean, yeah, you can see there's a couple of nicked tiles here and there. But honestly, this isn't too bad. I was expecting more to fall off than that. Did the shuttle have issues with tiles coming off when they first tested it? Actually, they didn't have issue with tiles coming off during re-entry grapes. They had issues with the tiles absorbing water. The tiles would absorb water, and they glued the tiles on because, for reasons. They glued the tiles on, and the water basically washed the glue off, and the tiles popped off like after the thing landed. Yeah, that's what they had problems with. Yeah, never had problems with re-entry or anything, but then again, those tiles were glued to an aluminum shell, right? These tiles are bolted to a stainless steel cryogenic shell. This isn't like bolting them to a shuttle, right? That, you know, that's an aluminum shell like an airplane, right? This is bolting it to a fuel tank, basically. A fuel tank that's masquerading as a space shuttle, right? That's what Starship basically is. It's basically a reusable upper stage. That's the right way to look at it. That you're talking about different thermals here. Come on, man, wake up. You're talking about different thermals here. Like bolting into a fuel tank, you have to deal with thermal expansion and contractions from having a full tank of fuel or not. This would be like bolting tiles to the external tank. You know, a little bit different. Yeah, SpaceX's tiles are bolted on. Damn, Ice Mage. The external tank design is maybe more clever than what we thought. Yeah, NASA knows what they're doing, Supercraft. The shuttle... Super, I'll say it once, I'll say it again. I'm basically a shill for the damn shuttle program. The shuttle's freaking genius. It's freaking genius. I'll just say that right off the bat. It's... How else do you solve that problem? How else do you make a reusable spaceplane like that? With thunder, apparently. Jeez. How much sleep do you usually get? 6 hours would be good enough for me, Steam. That's how much sleep I usually get. When it goes below 4... 5 hours I can handle. When it goes below 4, that's when EJ starts to have problems. Yeah, Devlin, I'm at about 6 hours, dude. I can do 6. 6 is fine. 8 would be ideal. 6 is good enough. God, I hope I don't lose power. We got cows. Okay. The Dinglebop here and the test tank are being moved. I rewatched the 135 undocking the other day. Amazing seeing it at the ISS. It is an awesome piece of equipment, Grapes, isn't it? Oh, okay, Ice Mage. Yeah. Yeah, Joe, those look like hydraulic rams to me. I don't think they're overwrapped pressure vessels. I thought those were the hydraulics. Or am I wrong? I don't know. Holy crap, that thing is big. On the side of the road. Oh, y'all come back. Yeah, okay, I got you. What if we just pick this thing up and put it over there? Bro. Sneak peek. Oh, cool. Bro. That cable management, though. Oh, that's beautiful. Oh, I love it. I love it. I love it so much. Oh, that's so nice. Severe thunderstorm warning for the next 45 minutes. 60-mile-an-hour winds. Penny-sized hail. Oh, shoot. Uh-oh. Go get the truck inside? Truck's in a storage yard, man. I'd have to go to the storage yard. The Mustang is outside. I don't have any place to put it. I don't have any garage to put it in. That's what the NWS is saying. Yeah, I got you, Devlin. Also, that cable management, though, is really nice. Well, just gonna have to hope it doesn't crack the glass or something. Mustang might get turned into a golf ball. It's not gonna make me love the car any less, so no problem. So this test tank was BN2, but they just put a Starship thrust puck in it. Yeah, it's very... Joseph, it's very weird. I got the idea why they slapped the Starship Dome into the booster section. They don't want to waste a thrust puck on a test article. And they all all they needed to do is exert force on the walls for testing, so they just used what they had. I agree, Basia. I think they took the Starship thrust puck and put it in there to get a similar idea of what's going on. And then the outer walls of this, they sleeved it with a super heavy booster. They sleeved the thing. Like the outer walls are a heavy booster. That's what I think this test article is. This is tested. It's a dynamic test stand for super heavy. I think you are 100% right. What was the estimation on that booster puck cost? 10, 15 G's, depending on what you made it out of. I asked my dad about that, who knows, he was a machinist. He sells the tooling for machines now. I asked my dad about it. He said, yeah, 10 to 15 G's, depending on what you made it out of. Like, machining is his wheelhouse. What's a thrust puck? It's the puck-shaped structure that absorbs the thrust from the rocket engines and transfers it to the rocket. 2.1 has pistons pushing on the main and 3 vac mounts as well. Interesting. Interesting. Huh. I don't know what to make with any of this information. Oh, yeah. Huh. Huh. They must. This thing must be there to deal with to test the thrust loads that super heavy will be. It's there to test the thrust loads that super heavy will have during ascent. I'm 100% sure of that. It's a dynamic test stand moving around on a little roly-poly right there. Cacti. That's weird that they kind of pulled off to the side. Thomas, did they pull these things off to the side for the static fire test and then bring them there? Because see where the police lights are on the left-hand side of this? Well, you can't see it anymore. That's where the road closure is. Yeah, okay, cool. Why did they need the dish pointed at a test? Telemetry downlinks from Starship. Oh, look at that. Oh, they have the hydraulic rams plugged directly... They're plugged directly onto a Raptor's gimbal. Look at that. Dude, this structure is freaking gigantic. Dude, one of those hydraulic jacks could lift up a freaking tank. I'm not talking like a tank like that. I'm talking like armored vehicle. One of them could probably lift the whole damn thing. Bro. Hi. This just looks so strange. I don't want to get DMCA. Is this a test base? That's what these are, Steve. Yes. I also think that the hydraulic test stand will eventually be permanently installed to the right of Pad B. Yeah. This is ship 21 now. Will this be the end of Booster 3? Maybe. Based on the FAA renders. Yeah, the programmatic assessment. That sounds about right, Joseph. It's funny that they built the test stand somewhere else and then moved it. The thermal protection system on 21 definitely looks a lot better. Jeez. Oh. That's definitely aesthetic. I love thermal tiles. It's such a cool looking design. Yeah, entropy, right? Yeah. And then they put the test article on the test stand and then move the whole thing to where the test stand goes, you know? They didn't just build the test stand where it should be, right? They didn't build the test stand where it should be and then moved it. No, they built it somewhere else and just moved the whole thing. It's fine. Those had to be laid on by hand. Well, they're attached. They're bolted on by hand. Mm-hmm. The mechanical attachment points are put on by a machine. Here, I can show you. In SpaceX's Gateway to Mars video. Here, take a look. See? There it is. You just saw it. There's the mechanical attachment machine. It's attaching where the tiles should go. See that? There's your mechanical attachment points. It looks like a giant Fabergé egg. Odd. I got the video up. We're just going to have to watch it. That's ridiculous. Nuts. My inspiration grows. The two planned structural test stand areas are in the colored boxes. Alright, let's take a look. Booster Starship structural test stand. Yeah, there you go. Yeah, it's going right where they have Booster 3 right now. I'm going to guess that that one is probably, that test stand, that Dinglebop's probably going right there. And then the other one's going to go over here. SpaceX really hasn't started phase 2 of this, which is, see where this line is, guys? That, well, the blue line, this one, the solid blue line that goes here. That's where SpaceX really, SpaceX has gotten about half of this plan done. Oh my god, it's purple. Yeah, it is. It doesn't look blue. Yeah, that's fine. Just ignore what I'm saying. It's fine, just... Full res without the color boxes. Yeah, I see. And farm expansion. Yeah, see, they did all this. This is all done over here, but not this reflection pond or anything. Anything that doesn't have the... You see this pattern on it? The pattern? That's the stuff that they haven't done yet. Integration tower. This has been made. That's where the chopsticks and stuff are. Yeah, see the 2019 EIS boundary. They haven't done any of this stuff down here. Let me see. Toe fills love cross section. Yeah, okay. Interesting. Interesting. I wonder why they chose to do this way. Like, there's no coherency to this. Like, I'm not trying to say anything bad about SpaceX. It's just it's strange. No, it's not reclaimed. Huh. You know, did they just say, like, okay, we're gonna Like, you can tell that this was, you could see where the old Falcon 9 HIF would have been. This was supposed to be a Falcon 9 launch facility right here, right? And it was supposed to be the launch, the horizontal integration facility was supposed to be right there, and then there was supposed to be a crawlerway, so to speak, and the pad was supposed to basically be right where Starship's pad is. Yeah, like I'm trying to, what I'm looking at here is if there's any real like coherency to it, or did SpaceX just say let's just put this here because that's where we have space for it? It seems much more like that. Like there's not, and that once again, it's not like a mark, like a knock at SpaceX or anything. It's nothing to do with it. It's just, yeah, I'm just kind of looking at how it's all coming together. Why do I think Elon is going to test how fast he can refuel a Starship in orbit after he goes orbital? I don't know. The test after the prime thing is validate those tiles. That's what all of SpaceX's testing over the past couple of months has shown, that they're really trying to get those tiles right. That's the real important one. Even on the hop test, there were still some of the tiles. Jeez. Yeah, granted, I think it's much more that it's in complete flux, yeah. It does, yeah, it's ridiculous. See, the other pad is going to go, like, right here. It's going to be another tower right next to it. There's little triangles on the booster hold-down points for Starship. These guys? Yeah. Yeah, those, yeah. That's what they are. Mm-hmm. Like, I think they did this stacking test to see if the tiles popped off when they picked Starship up and took the compression load off of it. Because tiles did pop off when they picked it up, you know? They put the entire vehicle under tension when they picked it up with a crane. And that did pop tiles off. I hope so, Zeppelin. I hope so. Alright. I think we got everything, dudes. There's not much in the crawl today for space news. I mean, there's... Yeah. Let's take a look at the launches here. Let's see what we got. SLS? What about it? What about SOS, Tribrew? Do you think they'll ever get a mating mechanism such that they don't need the main lifts once it's in production? The man lifts, yeah. Yeah, Aces, of course. Your video. Oh, yeah, that's right. Alright, let's see what that's about, Vasya. Let's check the outgoing rocket launches. So there's a Vega launch on the 15th. The Artemis 1 pre-launch testing and checkout push. I haven't heard any new news about that, Tribrew. Have you? Also, did we see this? Yeah, I have that open. It's in here somewhere. Yeah. I don't know if you've checked this out. Jacobs begin Artemis 1 pre-launch test. Oh, okay. This is what you were talking about. The Phil Sloss article. Yeah, we'll read that up in a second. It just turned the 14th in Denmark, so I guess I'm turning 24 now. Oh, happy birthday, man. Yeah. All right, let's check the rest of it. So, Electron on the 16th. Astra is on the 19th. So we got some rockets next week, and then we have Soyuz launching a Galileo sat on the 22nd. On the 22nd, and then there's the DART mission, the Double Asteroid Redirect, which is a cool one on the 24th. All right, got a good amount of launches here. Let's see what's going on across the pond here. All right, Vasi, let's take a look. What's up?
На Восточном ключевая фаза работ по возведению пускового комплекса для ракеты «Ангара». Строители монтируют составные части стартового стола. Важнейшие элементы конструкции – лонжероны. Вес каждого почти 90 тонн. Главная задача для строителей – завершить большую часть внешних работ до наступления холодов.
Погодные условия сейчас благоприятны, но через неделю, через несколько дней уже пойдет отрицательный температура.
Sergei Kostarev. That intro though. So Cosmonaut. Alright. Let's see. Auto translate. Oh, this is gonna end real well. No, he's the guys. So this is Angara's launch pad. Workers. He's talking about them installing the green plate on the launch pad. Watch here.
На Восточном ключевая фаза работ по возведению пускового комплекса для ракеты «Ангара». Строители монтируют составные части стартового стола. Важнейшие элементы конструкции
They're assembling the components of the launch pad. Most importantly, the structural
лонжероны.
element.
Вес каждого почти 90 тонн. Главная задача для строителей – завершить большую часть внешних работ до наступления холодов.
Yeah, hangar rocket. Nice.
Погодные условия сейчас благоприятны, но через неделю, через несколько дней уже пойдет отрицательная температура.
So this is Sergei Kostarev. Sergei is I think he's the foreman for Angara's pad. What is he saying?
Холодов.
Погодные условия сейчас благоприятны, но через неделю, через несколько дней уже пойдет отрицательная температура. Естественно, в каждом помещении, где мы будем проводить работы, и будем поддерживать определенный тепловой режим. Есть оборудование, которое монтируется только при положительных температурах. Естественно, очень тяжелый впереди период у нас, зимний.
They're trying to get all the major structural components installed before it gets, well, really freaking cold. Yeah, is the end of that sentence. Yeah, to say the least. This is the thrust plate right here, or not the thrust plate. This is the structural plate with the hold down points on it.
Элементы стартового стола были привезены на Амурскую землю северным морским путем летом прошлого года. Груз весом 2000 тонн из Северодвинска доставило судно «Баренц».
They transport the things were made in Severodvinsk, and they were transported through the North Sea route on the ship Barents. And the Barents docked at Sovietskaya Gavan.
На 72-м Международном астронавтическом конгрессе в Дубае цинки космодрома России представили макет стартового комплекса, который впервые был создан российскими специалистами новой...
Hey, dude, Soyuz launch pad diorama. I want it. Link, please. Okay. So this is like a general update from Roscosmos, huh?
в интересах иностранного ведомства Европейского космического агентства. Старт для российской ракеты «Союз» во французской Гвиане. «Союз» из тропиков поднимался в космос уже 25 раз. Комплекс получился надежным, современным и перспективным.
Это придание пилотируемого статуса этому комплексу. Это небольшая доработка мобильной башни обслуживания. И это позволит часть, скажем, например, космический туризм перевести именно в Куру. Неплохая идея, потому что, в принципе, французская территория, удобно принимать иностранных гостей, и запускать их на российской ракете с российским кораблем с очень удобного наклонения орбиты. То есть это тоже вариант развития Куру.
Впервые астронавтический конгресс за всю историю мероприятия прошел в арабской стране. Планы на космос сегодня у Эмиратов амбициозные. И это несмотря на то, что в космосе они новички. В 2015-м...
That's what I thought I heard. Yeah, they were talking about launching people from Kourou. So a Soyuz capsule launching from South America. That's pretty cool.
Здесь только создали космический центр, а уже в 19-м отправили на российском корабле «Союз» своего первого космонавта. Год назад японская ракета вывела в космос аппарат «Алямль», что означает «надежда», для изучения Марса. В новом году по плану запуск лунохода. Судя по темпам и желанию попасть в космические лидеры, арабским Эмиратам вскоре понадобится свой космодром. А предложения на рынке есть. Цинки космодромы России. Тем более с опытом мировых успешных проектов.
Цинки космодромы России. Принял участие в главном научном мероприятии страны. Наука 0+. Макет стартового комплекса «Ангара-А5» стал одним из самых ярких среди космических проектов фестиваля.
Цинки представляет макет стартового комплекса для ракет-носителя «Ангара» на космодроме «Восточный». Экспонат пользуется довольно-таки высокой популярностью.
Впервые науку 0+, провели 15 лет назад по инициативе Московского госуниверситета. Сегодня фестиваль всероссийский и объединяет сотни научных институтов и предприятий по всей стране. Задача – сделать науку понятной и доступной каждому. Здесь читают лекции ученые с мировым именем, а научные институты демонстрируют передовые разработки.
Look at all the science that's happening here. Wait, what? Wait. Why is it spelled that way there and it's spelled that way there?
Активные участники и студенты в МГУ 4 года назад открыли новый факультет – космические исследования.
This is a science fair, basically, for showing up science. That's what nauka means. It means science in Russian.
Студентов уже свое видение космического будущего.
Ресурсы Земли не бесконечные, и рано или поздно все равно придется столкнуться с проблемой, что пора как-то покидать Землю, разгружать ее и лететь куда-то дальше. Нас слишком много на этой Земле, чтобы долго на ней сидеть.
Перспективный корабль «Орел» для полетов к Луне.
So they have a model of the Angara A5B here, and Proton over there, but they also have the Oriol spacecraft. So that's the Eagle. That's their deep space capsule that they're working on. And you can see it right there of it on an Angara rocket. Funny, you thought it meant unplanned spin.
Ионный двигатель для дальнего космоса. Однако, какие бы планы ни строили ученые, старт у них всегда один. Космодром. Космодром Восточный.
Космодром. No. Spaceport. Yeah. It was totally planned, yeah, right? В
научно-исследовательском институте стартовых комплексов имени Владимира Бармина состоялся научный семинар молодых специалистов. В Цинки это уже традиция. Каждый год у начинающих инженеров есть уникальный шанс выступить перед старшими коллегами со своими предложениями и научными идеями.
Нас поддерживают в изучении нового, и это здорово, что молодые сотрудники и студенты готовы предлагать новые варианты решений и реализации тех проектов, которые уже есть.
По итогам выступлений...
Were you listening? The rest is boring? I was gonna say, are you listening? Were you reading? Were you listening to what she had to say? Yeah, I'm on to you, chat. I'm on to you. You were looking at the model in the background. I was looking at the model in the background too. I'm not gonna lie to you. I was like, oh, Soyuz diorama, man. Look at the model. Look at the model of Baikonur back there. I really like that. Oh dear. Those train models were pretty baller though. Anyway, cool. All right, so let's get into the EGS update here. Let's take a look. This is coming from Phil Sloss over at NASA Spaceflight. Let's see. Kind of like seeing Russia wants to advance their space program. I want them to match us, which they are already outperforming NASA by having a working spacecraft flying. Ooh.
Discovery, go at throttle up.
Yeah, I guess. Hey, Lim, 2-month resub. Tiger Fang, hey, what's up, dude?
Discovery,
32-month resub. I'm back! Mac had a 7-month resub in there, too. All right. This is a Phil Sloss deep dive. Oh, the pictures. How deep is this sucker? Oh. All right. Shall we, chat? The Orion spacecraft and SLS rocket for NASA's Artemis 1 mission are assembled. The mobile launcher is reconnected to the vehicle, and the processing team at KSC is resuming pre-launch testing and checkouts in High Bay 3 of the vehicle assembly building ahead of its first rollout to the pad. The agency's Exploration Ground Systems, or EGS for short, and prime launch processing contractor Jacob started the final stretch of integrated testing and checkout in early November and are aiming to complete the remaining work in the VAB to enable the first trip to the pad around the end of the year. Okay, the upcoming stretch of tests conducted between the Launch Control Center and the VAB at Complex 39 will verify all the connections between the vehicle and ground systems, followed by final functional checks of spacecraft and rocket machinery. After the final closeouts, the integrated Artemis 1 vehicle will be rolled to Pad 39B for the first time for its last big pre-launch test, the wet dress rehearsal, currently projected to occur in January. A second, more complicated round of verification testing for the SLS core and twin boosters started this week of November 8th, after final preparations were completed by the integrated operations team, basically the people that put it together. The Boeing guys are finishing up some traveled work in the engine section to get us into a configuration to now go back to the integrated vehicle testing. EGS Operations Flow Manager Lily Villarreal said in a November 5th interview. Boeing is the prime contractor for the SLS core stage. The first flight article also served as a propulsion test unit for the core stage green run design verification campaign at the Stennis Space Center in Mississippi. The company is finishing up post-green run modifications ahead of the vehicle's first launch. Thermal protection system repairs for the full duration firing in the B-2 test stand at Stennis in March. Yeah, it caught on fire a little bit, but that was expected. That fire wouldn't have occurred on the vehicle had it actually gone up into space, because the fire can't really burn up there unless it's coming out of the rocket engine, because there's no oxidizer. December is the SLS valve testing month. Wonder what modifications they're referring to. Yeah. After a verification test of the mobile launcher umbilical release and modal testing in late September, EGS and Jacobs prepped the vehicle for the bulk of the ITCO campaign. Following a set of interface verification tests, IVT, at the end of the summer, this round of the IVT is now being referred to as the integration versus interface verification testing. In addition to bringing Orion in, I can't read today, man. In addition to bringing Orion in for stacking to complete the Artemis 1 vehicle in October, the mobile launcher umbilicals had to go through a maintenance cycle of inspection and repairs, then be reconnected. The umbilical reconnection was our most critical path, and we got all the umbilicals mated and attached and ready to go to be able to power up the core stage and boosters. All right. We're still finishing up the ICPS umbilical, or ICPSU for short. And that's the last one, and we should finish it up sometime later next week, so basically now. But that's okay, because we're going to take our time to do booster and core stage integration verification testing. A few days after Orion was mated to the SLS in late October, the two-connection Orion service module umbilical was attached to the spacecraft so it could be powered up for the first time after being stacked on the ML. There were no issues when we powered up Orion. Battery life is good and things went well there. Individual vehicle components were powered up during initial interface tests. In the upcoming tests, EGS and Jacobs will be verifying integration and intercommunications between the elements. Yep, got to make sure everything talks to everything else. Okay. That picture, though. So now we get into these big integrated vehicle tests to verify we have a good operational understanding that the updates have been made, and yes, they're operating correctly, and yes, we're getting the right readings in our control center. You're trying to tie these individual systems with our GSE systems and saying, yes, we are ready to go. Yep, they're just making sure everything talks to everything correctly. We're going to do the booster. We're going to do the boosters to the core stage, and then we're going to do the core stage to the ICPS. We've already done the Orion one. Interesting. We're going to get into program-specific engineering testing, and we're going to do functional checkouts of every little system out there to make sure there are no disconnects or any breaks in the system, whether it's software or hardware related. Once we're completed with that, we're getting into the big integrated vehicle test. The big IVT is going to be our first opportunity to test out the vehicle as one vehicle. You're going to run through all the ringers and make sure that everything is operating correctly. Currently, the core stage booster testing for the SLS program would begin next week, the 15th. After the part of the verification test is being performed this week. There will also be engineering tests on the ICPS after the in-space second stage of SLS completes its first integration verification. The SLS program, which makes its home at the Marshall Space Flight Center in Huntsville, Alabama, has a resident office at KSC, which is coordinated support for the upcoming engineering tests in the VAB. Yep. Yeah, RevHawk, right? It's definitely a lot of things we have coming ahead of us, but it's also very exciting. Constantino added, I was an old ISS manager back in the space shuttle SDS 134, 135 days, and now we're seeing a vehicle integrated in the VAB and we're watching people work. If you look across the center, Jacobs have people working every facility in the center, so it's a time of excitement. I mean, literally, we're having meetings. We're having meetings yesterday about, are we ready for the pad? Are we ready to get things moving? What's the next step? Cool. Currently, the planning schedule is projecting that the test at the beginning of this, the wet dress rehearsal at the beginning, or no, wait, hold on. I gotta back up. I skipped a paragraph. Why did I skip a paragraph? I can't read today, dude. I'll check that in a second. The most complicated ITCO test is a remaining end-to-end communications test that will involve NASA people, program centers, facilities, and networks beyond KSC. The COM end-to-end check is really the critical one. Oh. And it's really critical from a scheduling perspective because it really requires so many assets of NASA to be supporting it. And so we have to really align when we're going to do that because you're talking about getting a lot of assets coordinated. Oh, okay. Beyond integrated countdown and launch simulations for Artemis 1 that involve all EGS, Orion, and SLS support teams and other NASA centers, Villarreal said the communication end-to-end test brings in downrange and in-space communication systems that will be needed on launch day, such as TDRS. Okay. Tracking data and relay systems. I want to see this infographic here. Launch to splashdown diagram. Let's take a look. They'll use ground tracking stations, global positioning satellites, tracking data and relay, and then once Orion goes past the relay, right, they're going to use the deep space network. Goldstone, Canberra, Madrid. That's what GDSCC, MDSCC, and CDSCC mean. That's cool. And then once it gets back inside of GPS, it'll inside of TDRS and GPS, it'll start using that again. Interesting. And then it's going to use sat phone, Inmarsat. Interesting. Interesting. Look at that. For search and rescue, they're using sat phone. Huh. All right. What did you find yourself into? I don't know. Cool article, man. What do we expect to roll out? I'll check this in a second. I'm not sure what that is, Forge, but I'll look at it. That's pretty cool. TDRS and the Deep Space Network can coordinate with the same spacecraft, right? Bunny! 6-month resub. Thank you. CT-2, or Crawler Transporter 2, will carry the mobile launcher with the Artemis 1 vehicle out to the launch pad for the first integration of a flight-ready vehicle and mobile launcher with the pad systems that will be used for the final launch countdown and fueling. The mobile launcher and Pad 39B systems have gone through integrated verification and validation together, and the Orion and SLS vehicles have gone through their standalone testing, but this will be the first time everything is essentially in a launch countdown configuration. At the pad, a full wet dress rehearsal is the final pre-launch exam for everything together. That's end-to-end testing. The WDR is a full launch countdown that will see countdown preparations fully exercised for the first time, followed by a high-fidelity countdown that will look and feel a lot like launch day. Cool. It's the final countdown! Could they send network sats in the moon orbit for comm satellites like what we do in Kerbal? Sure. No way, Caviar. That's cool. I mean, the Deep Space Network and tracking data and relay system is both Goddard stuff, so it's not a surprise that they can work together on comms. Yep. That test will be cool in a bit, yeah. The EGS and Jacobs ground crews will load propellant into SLS and the ICPS for the first time at KSC during the wet dress rehearsal. The ground launch sequencer, GLS, oh, that's so cool. GLS is go for auto sequence start. VLS is go for auto sequence start. Oh, that's so cool. That's just like the shuttle. Following launch day countdown timing sequences and launch commit criteria. After the two cryogenic stages are filled with liquid hydrogen and liquid oxygen propellant and the propulsion systems and engines are thermally conditioned for launch, the launch team will initiate GLS automated terminal countdown sequence and the vehicle will be prepared for ignition. We're going to have shuttle flashbacks during this countdown. It's going to be just like it, and it's going to make me happy. Phil, yeah, I can't help but think of that in the back of my mind, man. I'm having trouble. With all this bad news on Artemis 2 and 3, knowing Artemis 1 is soon kind of makes it better. Yeah, it's pretty freaking cool, man. I just really wish they would just keep the momentum going, you know? Like, I mean, like they should get Artemis 2, and Artemis 2 should go in 2023. Moving that to 2024 is not a good idea. That's too much time between integrations, you know? There's all this stuff that you can do. Like, okay, so think about it like this. NASA goes slow with their integration, right? But they do that on purpose because of the infrequency. They write everything, so they got to basically write everything down, right? And don't get me wrong, they still should do that on the first time around. But, like, Jacobs, all the, they're talking about Jacobs and all these people that put this thing together. They're really not going to have to do any, what do? They just sit there. They're just going to sit there until 2024 when they decide to put another SLS together? Like, now, right after Artemis 1 launches, they take some time to analyze the data, and they should immediately start on Artemis 2. But then again, there's that whole you don't know better than NASA thing. You know? Also, see you down there for Artemis 1. Indeed. Indeed. Like, all that downtime, Bob, I understand. And when you're doing waterfall testing, like what NASA is doing, you have to take time to analyze the data, and then you'd apply that data to the next stack. Dude, that's going to take that long? Like, but then again, I get it. This is a development program, all right? It's supposed to take a long time. You want to figure out that stuff now so you don't have any surprises during operational missions, right? Like, NASA builds amazing vehicles and rovers, but they're so slow. Yeah. They can go faster. I don't see why, unless it's cultural. Yeah, right. Also, Artemis 2 reuses some Orion components. Yeah. Yeah. Squishim, what was your last? Are they using all the ground tracking stations like Ascension or Guam? No. Ascension doesn't exist. They demolished that ground tracking station when TDRS became a thing. No, fire them all and hire new people 2 years later and teach them all over again. Swishio, the messed up part is that that's what they did during the shuttle program, dude. SLS is a shuttle-derived launch vehicle. But they literally laid off all the people that knew how to put the damn shuttle together. There certainly was a time when saying you know better than NASA was a meme, but now, yeah. Isn't that the point of Artemis 1, so you can do Artemis 2 sooner? Yeah. There will probably be a lot of mobile launcher refurbishment. Well, yeah, maybe. And hopefully gateway modules will start showing up in the SSPF soon. Yep. I know, that's why I made the joke. Yeah, oh, okay, Swishy, yeah, I got you. Yeah. Really? Don't we still hear acquisition of Signal, Ascension, and on some Florida and Kourou launches? Kourou isn't NASA. The European Space Agency Kinez has a tracking station at Ascension, not NASA. NASA's tracking station there doesn't exist. Who's the guy behind Jim in Mission Control? That's Gary Lay. He's a lead engineer on New Shepard, the New Shepard rocket. Well, Gary, quiet down. Gary, relax. Yeah. Like, I understand why they need to go slow. It's just, yeah. Sucks. Can you ask Gary when orbit? I need to speak with you before 7:30. Okay. Okay, Forge, what are we looking at here? Is this PDF all the stuff that's gonna end up towards the moon? Sorry, it's stream related and stuff. Okay. All right, well, that's what's going on with SLS. They should finish all that ICPO and IVT testing soon, and we should see a rollout. The rollout is going to be the real thing that you want to see. That's going to be awesome. It'd be pretty cool. Who made this incredible mess of an infographic? I don't know. There was a lot of stuff on there that was outdated, though, Forge. All right. Anyway, I think that's everything, guys.